Hey everyone, my name is Jason with Mount Baker Mining and Metals, and this is all my slag and crucibles that I've been saving up over the last couple of years. And I want to figure out how much gold I lost in all of my different smelting experiments, lost in the crucibles. So we're going to process all this today and figure out how much more gold and silver I can recover. I'll get you a little up close and personal here. I've got all sorts of different buckets here of slag, a bunch of different recipes. I've got some fire brick that was crushed up when I spilled in the furnace. I got my crucibles. I've got some real glassy slag. I've got some powdery stuff. I've got some that stuff. And my theory is that over the course of the last couple of years, I've done a bunch of different experiments. I've probably lost some precious metals in this stuff, or collector metal for that matter. And so I'm going to run it through the jaw crusher, hammer mill, and shaker table, and I'm going to treat it just like I would a gold ore. And the idea is that all the collector metal or precious metal is now probably little tiny beads, either suspended in the slag or stuck in the crucible somewhere. So once we crush it and liberate all that stuff, it's going to be able to come across the shaker table into the number 1 and number 2 concentrates. We'll be able to recover that precious metals from all this junk. Wow. All right, well, finished with the run. I think I counted 14 buckets altogether, so there's a lot of slag there. The hammer mill, you could probably hear in the video, but there was so many nails and steel and stuff that went down there. It was just banging around, beating all sorts of stuff. It's kind of a combination hammer mill, ball mill at that point. But the stuff came across the shaker table under the cleaning plane, under the water bar there, and down into the number 1 and number 2. There was a lot of lead. I think it was lead, little tiny balls. There was some other stuff, some goldy looking stuff, which I think I may have mixed in some PCB slag with this stuff. So there may be a few little pieces of computer parts in there, but there shouldn't be too many. I didn't see a whole lot on the table. And we've got our number 1 bucket about half full. Our number 2 bucket I had to switch, so we have about 1.5 buckets of that. But yeah, I don't know. I don't know if we got almost all metal in number 1. At some points there was some stuff that looked like matte in there coming across on the shaker table. So I just really don't know what we got. We're gonna have to get it in a gold pan and swirl it around, and then I guess we'll just smelt it down and see what we can recover out of it. Here's a few pieces of steel I grabbed out before they went in the hammer mill. But here's a bunch of steel that ended up getting in the hammer mill, and I pulled out. But you can see there's some pretty hefty pieces in there. Roll stuff up into balls. There's a bunch of little pieces of nails and stuff coming across the shaker table. And there's like these little pieces. Those aren't gold balls or anything. I'm assuming those are little pieces of brass from the electronics recycling. So what I'm going to do, just to make sure, I'm going to pull all this steel out with a magnet, and anything that's not magnetic I'll just put in the furnace and we can smelt it down. Here's the number 1. I think it's about a quarter full. Here's the number 2. I don't know how much is in here. The other one's sitting over there, pretty much full. But one of the things that happened here is my slag, or my flux, uses a lot of soda ash, which is really basic, and when it smelts down it turns into sodium hydroxide, I think, or sodium oxide. And it's really basic, and it makes it feel like soap on your fingers. So it's turned my whole water bin here all to essentially basic, a little bit more basic, which probably isn't a big deal because it probably counteracts all the sulfides I got in there. But you can feel it when you get your hands wet in the water. All right, well, we got our number 1 here, and this is what I'm most interested in because that's where all the heavy metals should have gone. It's pretty heavy. I mean, there's not very much in there. It weighs about 1,100 grams. And so the first thing I'm going to do is I got to separate the slag and the junk and the matte from the metal. And so I'm going to mix up probably about, I don't know, 500 grams of soda ash and about 100 grams of silica sand and get that melted back down in this big crucible. I'll pour it into our cone mold, and then we'll get our metal pyramid that I can then refine the precious metals out of. But first I got to get rid of all this junk and all this water. All right, I got our stuff in here. I also added in about 100 grams of potassium nitrate to act as an oxidizer. And hopefully that potassium nitrate will oxidize away some of the base metals in there so we don't have nearly as much metal that we got to deal with. And hopefully a lot of those oxides that we create with the potassium nitrate will go up into the slag, and we'll have a fairly small button that we can then refine the precious metals out of. And this is kind of exciting. I don't know if I'm going to get 2.5 ounces of precious metals or if I'm going to get 0.25 grams. So I'm kind of excited about this experiment. Here's our last little bit of the number 2 concentrates. And I pushed this one pretty hard. I poured some water on it, tried to get it to cool down fast. So hopefully the lead is not molten in the bottom here. That looks pretty good. What do we got here? Whew. Still gooey. And actually, I don't know, I might be able to get it up there. There's a matte layer right there. So we got some matte in addition to our lead, our button, our metallic button. So that's all slag there. Interesting, we didn't get any matte on our other 2. Well, here's our 3 buttons. This is the number 1, first batch number 2, and the second batch number 2. And altogether, we have about 1 kilogram worth of metal, which is a lot. That's a lot of metal that I lost over the years. I think it's mostly lead because the buttons are quite soft. They're malleable. I can hit them with the hammer and they're not brittle. But I don't want to QPel all that lead away. That is just a ton of lead. So what I'm going to do is I'm going to put them in a crucible again, melt them up, and I'm going to pour them in a bucket of water and cornflake it. And then I'm going to put them back in the same crucible with a bunch of potassium nitrate. And then we can hopefully oxidize away a bunch of this stuff and get it down to maybe 100 or 200 grams of lead or base metals that I can then put in the furnace and QPel away and refine those precious metals. All right, let's see if we accomplished our mission here. That's that old slag water, it's all black. But I want to get the lead with a huge amount of surface area. So when we put it in with the oxidizer, there's a lot of surface area for that oxygen to react with. How's it look? Oh yeah. See that? It's all cornflaked lead. I can get a little better look at it now. Let's see, it's just cornflaked is the term, but it's just got a huge amount of surface area now. When it hit the water, it just kind of splattered and cooled really fast. So now let's get this mixed up. Some potassium nitrate in the crucible, and we'll hopefully reduce it from 1,000 grams down to 200, hopefully. We'll see what happens. Well, my chemistry is a little bit rusty, but we've got about 1,000 grams of lead here, and each mole of lead weighs 200 grams, roughly, right about 200 grams. So we have total about 5 moles of lead here. To oxidize all that away, we need about 5 moles of oxygen to combine with the lead and oxidize it all away. So I have 500 grams of potassium nitrate here, which potassium nitrate is about 100 grams per mole. So for 5 grams of that, each mole gives off 1 oxygen, which will combine with our lead to form PbO. So for our 500 grams of potassium nitrate and our 1,000 grams of lead, that should equal 1 oxygen atom for every lead atom. And it should oxidize all the lead away. Now, in practice, that's probably not going to happen because the surface area of the lead isn't there. We don't have, as a lot of this oxygen is going to go off into the atmosphere when we smelt it. But it's a good place to start. We have roughly what we need. So we're going to smelt this down and figure out how much lead is oxidized away and how much we're left with. There you go, that's what it looks like. So we'll get in our crucible and see what happens with it. Oh, what the heck, I'll add a little bit more. I'll add another 200 grams potassium nitrate. Now we have 700 grams. So hopefully that'll help us oxidize some more lead. There we go. We got probably about a third to a half in our crucible. And the danger with this stuff is it releases so much oxygen so fast that I hope it doesn't just froth and boil right over in our crucible. But we'll see what happens. Well, this is all our slag, and I added a bunch of iron to it to try and reduce out all the lead and copper we oxidized. Let's see what we got. Now, unfortunately, it was my last smelt with that crucible, and the crucible leaked. So I leaked all my slag all over the furnace. But there is the metal, the oxides that we reduced from the slag by using iron. That worked pretty good. I'll get it cooled down and get a weight on it, but we reduced quite a bit of metal back out of that oxidized slag. And there we go. We recovered 500 grams worth of metal. And that's not really that important. I mean, that's mostly probably lead, a little bit of copper in there. We had a 70-gram button that's over in the Cupelling furnace right now. So we were able to recover about half the metal. Again, not important. It's not worth anything. There shouldn't be any precious metals in there. But it was just kind of a cool chemistry experiment to try. And maybe if I left it in the furnace a little bit longer, or actually, you know, that I'm thinking about it, we may have lost a bunch of metal in the bottom of that furnace because the crucible leaked. So anyway, it's not really a conclusive test on how much you can recover from your slag, but we recovered a significant amount, even though we probably lost an appreciable amount in our furnace. Yeah, I was just walking around cleaning up, and I noticed this. This is where all the slag and probably a bunch of metal leaked down when that crucible failed out the bottom of my furnace. And that's one of the reasons why I like to do these cheap wraps of KO wool and fire brick, and I just use cement for the base because it's super cheap. I have crucible fails, I have boil overs, and it's a lot easier. I can just lift that thing off now when it cools down, sprinkle a little bit of cement over there, chip the slag away, and put the thing back on, and we'll have a furnace going again. So I just want to check on our button here. That, I don't know if you can see it. That is what it looks like when a button's pretty much done. You get this kind of rainbow of colors. The last little bit of oxides are starting to go out of it. And that is a huge button. Huge. So what I'm going to do is I'm going to add a little bit more lead, maybe 10 more grams, just to make sure we get all the base metals out of there. But man, that's a huge amount of precious metals. Well, I've turned the furnace off. I just let it cool down slowly in the furnace. Try and avoid any silver sprouts, because I'm assuming this button is mostly silver. Man, that's a lot of silver. A little bit of oxides on the surface there I didn't get off, but we'll get that out of there and get a weight on her. All right, moment of truth here. 70 grams. I'll be darned. So that means that the little pearl we got at the end of the second smelt was pretty much all silver. That's quite amazing. So that actually worked really good to cornflake the base metals and oxidize them, and we didn't have to Cupel hardly anything. All right, guys. Well, that was an interesting video. Obviously it makes sense to save all your stuff and reprocess them if that's something that you have a significant amount of silver or gold. I've thought several times about where this comes from. I don't deal with a lot of silver. There's been 3 different projects that I've worked on that have a lot of silver in them. One was processing some film residue for silver, and in that one I got a bunch. I got I think almost 2 pounds. I can't remember now. The second one was when I processed some industrial brushes for a guy, and there was a bunch of silver in that. And then the third one was the Cerro Gordo smelt, where I recovered quite a bit of silver for Brent out of his lead and his ore. So I'm assuming that that's where most of this came from. I'll put some links up, I don't know, one of these corners, and you guys can go back and watch and see if you can spot where I screwed up and where I lost most of this silver. But I'm really happy with the ability of cornflaking a bunch of base metal, collector metal, and then oxidizing it away so you don't have to Cupel, a kilogram worth of lead. You can oxidize it away and then have a much smaller bead that you got to deal with. So that works out really good. And in addition to that, that tells me that I can take a kilogram of lead, use it over and over and over again as a base metal collector, and then, so for several smelts, maybe 5-10 smelts, continually enriching it, and then you can, at the end of that, when you're ready to recover your precious metals, you can oxidize away all that lead by cornflaking it, putting in oxidizer, and then recovering your precious metals. So I hope you guys enjoyed this video. This was a really fun one for me. I was not expecting to recover this much silver. There's probably a little bit of gold in here as well. And I will end up probably refining this sometime in the future to really figure out how much gold and silver we have. So thanks for watching, and we'll see you on the next video.